Hey there, science fans! Today we're diving into the fascinating world of formulation science. It's all about mixing stuff together to make awesome things. And guess what? Humans have been at it for ages. Think back to ancient Egypt. Those stylish Egyptians were masters of makeup. They created kohl eyeliner using ground-up minerals like galena and malachite. These natural ingredients were carefully combined to create smooth, long-lasting eye paint. Talk about ancient beauty hacks. Now let's zoom over to ancient Rome. The Romans were known for their incredible architecture, and their secret weapon was concrete. By mixing volcanic ash, lime, and water, they created a super strong building material that has stood the test of time. The Colosseum, anyone? These early examples show that formulation has been around for centuries. From cosmetics to construction, people have always been fascinated by mixing ingredients to create something new and useful. Fast forward to the 18th and 19th centuries, chemistry was booming. Scientists were busy discovering new elements and figuring out how they interacted. This knowledge revolutionized the world of formulation. Instead of relying solely on trial and error, formulators could now use chemistry to understand the properties of different ingredients. They could predict how these ingredients would behave when mixed together. This led to the creation of new and improved products, from medicines to paints. One of the most significant breakthroughs was the development of synthetic dyes. Before this, dyes came from natural sources like plants and insects, which was time-consuming and expensive. Synthetic dyes, on the other hand, could be produced in large quantities and in a wider range of colors. This revolutionized the textile industry and changed the way we think about color. With chemistry as its guiding star, formulation science was poised for even greater things. The Industrial Revolution was a game-changer for formulation. New machines and technologies made it possible to produce goods on a massive scale. This meant that everyday products like soap and candles could be manufactured quickly and affordably. Remember those synthetic dyes we talked about? The Industrial Revolution allowed for their mass production, making colorful fabrics accessible to everyone. This was a huge shift from the days when only the wealthy could afford brightly colored clothing. The rise of mass production also led to new challenges in formulation. Products needed to be stable and consistent, even when produced in large quantities. Formulators had to become masters of quality control, ensuring that every batch met the required standards. Section 4. Modern Marvels, Sustainability and Beyond in Formulation. Today, formulation science is more innovative than ever. Scientists are exploring new frontiers like nanotechnology to create products with incredible properties. Imagine sunscreen that's invisible to the naked eye or bandages that can heal wounds faster. That's the power of nanoformulation. But it's not all about high-tech advancements. There's a growing focus on sustainability in formulation. Scientists and companies are looking for ways to create products using eco-friendly ingredients and processes. This means reducing waste, using renewable resources, and minimizing the environmental impact of manufacturing. Another exciting trend is personalization. Thanks to advances in technology, it's becoming possible to create customized products tailored to individual needs. Imagine skincare products formulated specifically for your skin type or medications designed with your unique genetic makeup in mind. The future of formulation is personal. Section 5. Cracking the Code Key Concepts Explained. Now let's get down to the nitty-gritty of formulation and explore some key concepts. Don't worry, I'll keep it simple. Solubility. This is all about whether a substance can dissolve in a liquid. Think about mixing sugar and water. The sugar dissolves completely, creating a clear solution. That's solubility in action. Stability. A stable formulation stays the same over time. It won't separate, change color, or lose its effectiveness. Like a good friend, it's always there for you. Viscosity. This refers to a liquid's thickness or resistance to flow. Honey is more viscous than water. It pours slowly and feels thicker. Viscosity is important in products like shampoos and lotions, affecting how easily they spread. pH. This measures how acidic or basic a substance is. The pH scale ranges from 0 to 14, with 7 being neutral. Lemon juice is acidic, while baking soda is basic. In formulation, pH can impact a product's stability, safety, and effectiveness. Emulsification. This is the process of combining two liquids that don't usually mix, like oil and water. Think about mayonnaise. It's an emulsion of oil and vinegar held together by egg yolks. Dispersion. This involves scattering small particles of one substance evenly throughout another substance. Imagine adding cocoa powder to milk. When mixed well, the cocoa particles are dispersed evenly, creating chocolate milk. Section 6. Ready, set, formulate. Congratulations! You've just taken a whirlwind tour of formulation science, from its ancient roots to its modern marvels. We've explored how chemistry, the Industrial Revolution, and a passion for innovation have shaped this fascinating field. And we've just scratched the surface of those key concepts: solubility, stability, viscosity, pH, emulsification, and dispersion. Don't worry, we'll dive deeper into each of these in future episodes. Stay tuned for more science fun.